take over the session and enlighten us with her valuable knowledge. Over to you, ma'am.
Thank you for giving me this opportunity to talk to physics people. So I'll talk about eclipses, in particular the lunar eclipse, because I think most of you have seen the eclipse yesterday. Are you able to see the PowerPoint?
Yes, ma'am.
So this is what you saw yesterday, and my colleague Mr. Pramod Galgali took this photograph from Bangalore. So let us start with this beautiful photograph. So we look for records of eclipses. That means why should people be looking at it? Why should people record it? And so on. So yeah, you have seen just now a photograph, but what did they have in the past? Excuse me. So the earliest record is on the Babylonian clay tablet. So people have been able to decode this things written here, and they have found that it is actually a record of eclipse. And we also have Chinese records from 1361 BCE and 1217 BCE. They have been maintaining logbooks, and therefore we have a lot of records written in their books. And among the Indian records, the earliest reference to an eclipse as recorded in history can be traced to Samrat Ashoka. As you know, he sent missions to spread peace to all Asian countries. The first one was Sri Lanka. So the day these people set out for this mission was the day of an eclipse, and he ordered that soon after the eclipse they should start their journey. So that is how we come to know that there was an eclipse during his days. I mean, it was not recorded as a celestial event, but it just happened that that day was an eclipse day. We also have records of kings donating lands and gifts on the eclipses. So I have many stone inscriptions, these kinds of records. And the other thing is the saints, they were doing self-immolation, that means jumping into the fire on the day of the eclipse, believing that that will fetch them salvation. And there were also women who opted to for sati, and that was also performed on the day of the eclipse. We have records of such stone inscriptions. So this is, for example, one such inscription where at the center somewhere here, you will see that there is a record of an eclipse and the name of the person who underwent this self-immolation. And if it is a sati, you will see this kind of a symbol also. If you see the hand up like this, that means that is a sati stone. So there are several such stones all over India. And if you read the thing that is written carefully there, it will also mention the name of the lady and the person who, her husband, whoever died, and what was the cause of that, whether he died in a bar or whether he was fighting with a tiger to save the villagers. All such details will be provided there. And so this is looked at by the historians for a different perspective, whereas I looked at them treating them as records of eclipses. That way they are very valuable records of eclipses. And there are also things, yesterday most of you have seen the eclipse. So if you have seen it, you feel like sharing it. Say, for example, you took a photograph. And artisans also did the same thing. And so these are the kinds of engravings we see in temples. So the snakes are linked to the eclipses based on some Puranic story. And so this is a lunar eclipse, this is a lunar eclipse, this is a solar eclipse. These are all engraved in a temple of maybe 15th century in Karnataka. So I'm sure there must be such engravings elsewhere in India also. You should look for these kinds of drawings, and perhaps that will tell you that the artist was himself very impressed by the sight of an eclipse, and therefore he decided to engrave it. This is another interesting painting in Amritsar on the wall. Guru Nanak gave a discourse on the occasion of the solar eclipse. So this is the occasion, and here is the drawing of the eclipse that is painted there. This is not a very old one, maybe 200-year-old, but then the artist decided to draw this, maybe because he saw an eclipse and he was impressed by the sight of that. And you can see the paper by R.C. Kapoor on this particular subject, which is published in Current Science, and he gives the details of these things. Now, there are two things. One is an eclipse actually happened during the life of Guru Nanak. The second is an eclipse happened during the life of the artist who saw it and he drew the picture. So both are possible. This artist belonged to some 18th century. So the eclipse is depicted all right, but is it described in Guru Nanak's biography? That part we do not know. Or he imagined that this should have been the site and therefore the artist drew it in the 19th century. So these are the questions that come up to us. But in any case, even if it is a 19th century painting or 18th century painting, it's a record of an eclipse. If we can trace the date of this, it will be a wonderful addition to the history of records of eclipses. This is another interesting thing by it's a 18th century artist. The whole family was known for these kinds of paintings, and this is an episode from Bhagavata. Bhagavata describes that Krishna and his family, Nanda Gopa, everybody, they went to Kurukshetra on the occasion of an eclipse to take bath in the holy water there. So this is the thing that is depicted here. And if you just look at this, you are not able to make out anything because what is it that they are seeing? You will wonder. But if you observe this part carefully, you will notice that it represents the eclipse. This is, for those of you who have seen a solar eclipse, you can easily recognize that this is almost total eclipse or annular eclipse. That means definitely the artist had seen such an eclipse, and therefore he decided to immortalize what his experience was by this painting. This painting is in Washington Museum, it's not in India. So the eclipse, as mentioned in Bhagavata, may be total, may not be total. That is not very carefully written there. But the artist definitely saw this, and therefore we can date which particular eclipse is the one that he saw. Because this is as late as the 18th century, you can see the influence in the dresses of these people. So this is supposed to be Nanda Gopa, and this is Krishna, and so on. So the influence is very clear. Basically, how we understand eclipse is from observations. Eclipse is something very interesting. So you feel like watching it. So what are the observations that you can make? As I mentioned earlier, I'm concentrating only on the lunar eclipse. So when you see the moon any day, what your mind is the difference in the shape of the moon. So yesterday you saw the full moon, and today evening you will not see the moon at 6 o'clock as you saw yesterday. One thing is that you have to wait. You have to wait for seeing the moon. And then you may see something in between these two. And a week later, you will see a half moon in the morning. And a few days later, you will see a crescent in the morning before sunrise. And then after a week, it comes to evening as a crescent. So this is the kind of periodicity that you observe. There are two things. One is the time delay. The second is the change in the shape of the moon. The other thing is, if you imagine a circle here, the circle will always have the same radius. It always has the same radius. So you are definitely seeing part of a sphere. So here I have given a particular event of this month later on the 30th. So 30th, if you watch the moon, you will notice an interesting thing, which is something similar to an eclipse. The star called Magha will reappear from this side of the thing. So you can make a note of it. So please take a look at the moon on the 30th dawn. Okay. Yesterday you all saw the eclipse. So this was the way you saw it. At least people from the northeast would have seen this phase. So now this is also looking gibbous. This is also looking gibbous. Is there a difference? That is the kind of observation you have to make and try to understand that yes, there is a difference between the two. So this phase is different from this. So why should the moon take up this kind of a shape when it is not the 10th day, but it should have been looking like this? So that is the kind of observation you have to first make, and then you make systematic observations, and then it becomes a tool for predicting the eclipses. So what is the cause of the eclipse? Why should there be a lunar eclipse? This was very well known from our old records. We can say even before Aryabhata, before that, it was very well known. For example, Varahamihira very clearly states, in lunar eclipse, moon enters the earth's shadow. Earth's shadow has a name in all astronomy textbooks. It is called Dhubha. That's the name that is given, the shadow of the earth. Or it is also called sometimes Tama. Tama is the darkness. So darkness itself is defined this way. And he clearly says that in solar eclipse, the moon covers the disk of the sun. That is the first half of this phrase. And the second part is very interesting. What does this say? It says that the lunar eclipse commences from east. The solar eclipses commences from the west. What does this mean? This is something very interesting to understand. As we proceed, I will explain this with the help of the logic that is in use. That means already people knew that there is a definite eclipse, a physical cause, which is creating this kind of a celestial event. It was very well known, well established. Now, this is the meaning of east and west. Now, here I am comparing the phases of the eclipse and the phases of the moon. So here it is. So when it starts with a new moon day, then you have a waxing crescent, then you have a first quarter, then you have a gibbous, a full moon, then a gibbous, then a half, then a crescent, and then the new moon or no moon. But in the case of lunar eclipse, it starts with a full moon, and you see a part is covered, and then another part is covered. And then when we saw yesterday, it was almost covered like this, and we saw only a small portion like this, but the rest of it was of a different color. This is another thing that you all must have noticed. And then if it is a total eclipse, you will see it as a completely red object, and then it repeats. Now you observe that this half moon is different from this half moon. You see the shape here, there is a difference. This is the kind of observation that you have to be making. And people did this for thousands of years before arriving at the actual cause or understanding the actual cause of the eclipse. So the observations were very profound. One of them is something easy that you also can do. Lunar eclipse, for example. Yesterday you had a lunar eclipse, and 22nd February 2008 there was an eclipse. There is going to be an eclipse on 12th March 2044. So here are the 3 dates, definitely. In between there were eclipses. But look at this. These 3 are separated by a fixed interval. Okay. So what is it that caused this periodicity? 18 years, 10 days, and 8 hours. That is the periodicity. So how did this happen? What causes the 18 years periodicity? If you see an eclipse, for example, 15 days ago, there was a solar eclipse. Again, add 18 years, 10 days, and 8 hours, you will get the next eclipse. You subtract the same days, then you will get so you can predict it yourself. You need to know when is the eclipse happening, and you should have seen the eclipse. Okay. So here is, this is for lunar eclipse. It's true for the solar eclipse also. So here, for example, from 1901 to 2000. So this is the first eclipse of the that century, 1901 here. And 18 years, 10 days later, there was this is the path of the moon. This is the path of the moon of the central, where they saw the total eclipse. So this is after 18 years, and this is after 18 years. This is where the 8 hours comes into picture. Because of the 8 hours, it is shifting by exactly 120 degrees. And then the next one happened here, 1955. After that again, 18 years. After that again, 18 years. And 2009, we had seen one eclipse which passed through central India. And you have again in next year, 2027. So the difference is exactly 18 years and 10 days. So now you know the trick. So you can predict any eclipse. So this is the kind of observation that took place, that were recorded, say 3,000, 5,000 years ago. And then they were trying to find out what is the clue for this 18 years. So the story of Rahu and Ketu I'm eliminating. I don't think I need to tell you the story of Rahu and Ketu. It's so well known, it's popular. Take it as a story and remember it because it's a very interesting story. Leave it at that. But we will use the names Rahu and Ketu. We will need those names. I'll tell you why. Oh, incidentally, after India became independent, there were no systematic observations or no observatories existed as we have today. Today we have so many observatories functional all over India. So you must have read about Professor M.K.V. Babu. He was instrumental in, he is called the father of observational astronomy in India, independent India. He returned from his PhD program from US. And the first eclipse expedition he led to Sri Lanka in 1955. See, Sri Lanka had the path here. So that was the first ever eclipse expedition from independent India. That way also this is important. And the same series, this is called a Saros cycle. The same cycle we will have a eclipse next year in 2027. So that is important. Now this is another example. In the year 2002, there was an eclipse. This was solar eclipse, and that's the shadow of the moon. And then 18 years later, 2020, we had another solar eclipse. See this, we all saw, many of you might have seen this, it passed through India. So this was another eclipse. And then when is the next one going to happen? Now you can add 18 years and declare the date yourself. So that is 1st July 2038, and that's the path. Now because of the 8 hours difference, now the path where it is visible is different. So here it was visible, but here and here it was not visible. And 3 such cycles later, again it becomes visible in India, as happened in the last case. So this is the kind of observations that you have to first make and appreciate the fact that there is a periodicity and we need to understand the cause of that. So when we try to understand the moon's orbital cycle, there are 3 such periodicities for the moon. One is called the synodic month, which you are all familiar with, which we use for civil purposes. Our names, you know, Chaitra, Vaishakha, and so on. They are the synodic months, starting from new moon and ending with new moon. So we call the first day as Prathama, Dvitiya, Tritiya, and so on. That has a periodicity of 29.53 days. It's not an integer number. So from there is one more periodicity. If you take from one star, there are 27 stars to mark the position of the moon. The time taken for it to come back to the same star is also a sidereal period that is not exactly relevant here. The moon's orbit is elliptical. So there is a point called perigee when it is closest to the Earth. The time needed for the moon to start from the perigee and come back to the same point is slightly different. It is 27.55. And node, I will explain you what is node. It is also called as the draconic month. In just a few more slides, I will explain. So that date also is different. And this node is the one which is called as Rahu. So let's understand what is that node. So I'm trying to make you understand that part. So if you take the time required for 223 synodic months, 239 anomalistic months, and 242 draconic months, a simple calculation will show that they are all 6585 days. 6585 days. There is a small change, but for this current year, this is the order, and this corresponds to 18 years, 11 days, and 8 hours. So this is the reason for the periodicity of eclipses. Now, to arrive at this number, that is these 5-digit numbers here, accuracy, these numbers which are accurate to 5 in decimal points, it would have taken them thousands of years. But at the end of that, they were able to establish that there is a periodicity of 18 years, 11 days, and 8 hours. 11 days or 10 days comes if you have a leap year in between. That is taken care of. So it was very well known for lunar eclipses, but as I showed you in the earlier slide, it is apparent in solar eclipses also. So how did our people record it? I am giving you the quotation from Varahamihira. And okay, here I have to remind you the story of Rahu and Ketu. Rahu and Ketu were considered to be the cause of eclipses. It was believed that it has the head of a serpent and the tail part is called Ketu, and they eat the sun and the moon periodically as demons. You know the story associated with the Amrita Mathana and how they were created and all that. But by the time of Varahamihira, the story also was popular and the mathematics also was very well established. So he asked a question: if Rahu has a head and a tail which are 180 degrees apart, so the head eats the sun, the tail covers the moon. So this is the logic. If you say, then why it has a body, so it should cover the stars in between. Why doesn't it do that? So this is not a believable story. So don't believe this. This is statement he made in the 6th century. Please remember. And how did they record the 18 years periodicity? So these are the number of, they don't give the periodicity in the notation that we use. For example, just in the previous slide, I said the sidereal period is 29.53 days. No, they don't give. They give like this: number of sidereal revolutions of planets in a kalpa. What is kalpa? Kalpa is this large number, this many number of years, 4.32 billion years. In 4.32 billion years, moon makes so many revolutions. I can't even spell it out. 57753336000. That many number of revolution it makes. So what is the time taken for one revolution? You do the division and find out. Similarly, for Mars, Mercury, Jupiter, everything they give. And look at this last entry. This last entry corresponds to 23238, the node. The node is the one which is responsible for the 18-year periodicity. And if you do a simple division, you will get this. This is from Surya Siddhanta. This is from Siddhanta Shiromani of Bhaskaracharya. And this is from Aryabhatiya, 5th century, Khandakadhyaka, 9th century, Mahabhaskariya, 6th century. By then, these numbers were all established. And you see the small differences here. These small differences are the ones which are indicating the number of decimal places to achieving the accuracy. And here also you notice that the numbers slightly different. So because of that, they had to keep on correcting it after every eclipse observation. And so those corrections were called as bija. Bija was the word that was used for correction. Now let us understand the physical meaning of this node. Now as it goes here in this table, it means that the node is a thing in the sky, it has a periodicity of 18 years, and that when it comes with the sun and the moon, you have the eclipse. So what is it? So here you can have it as a model to explain the eclipses and some kind of an order. So I will go to the simplest way of explaining this. So the earth is at the center. The sun is going around the earth in an orbit, and the period of that is 1 year. The moon is also going around the earth. That orbit is slightly different. It is not the same as that of the sun. And it takes 1 month. The moon will come back to this position after 1 month. As I told, 1 month is a very general term. The month has several types of definitions. As I mentioned, sidereal, synodic, nodic, draconic, and so on. Okay, let us take this as approximately the word month. It returns. So the two orbits, this is one orbit in the dashed line, the other is the other orbit. The two intersect at a point which is called as the N1 here, and it intersects at another point which is called as N2. So these are the 2 points which are called as Rahu and Ketu. Which is Rahu and which is Ketu? That is easy. So suppose we consider this as the orbital plane, this is north. At N1, moon is going from south to north. This is ascending node, this is called Rahu. N2, the moon is going from north to south. When I say north to south, you don't imagine it is coming from here to here. Slightly to the north of the path of the sun, called the ecliptic or the Krantivritta, and it comes slightly to the south. The difference is not much, it's just 5 degrees, but that is the root cause of eclipses happening and not happening. So let us say when it is here, when moon is here, the sun is also here. Then definitely the two are aligned and therefore you have an eclipse. On the other hand, suppose the moon is here in this position and the sun is here. They are aligned for the new moon definitely, but one is above the other or below the other, and therefore there is no possibility of eclipse. So this is how they were able to visualize the event as it is happening in the sky above them. And so it's a very difficult thing. The challenge is that they had to first of all imagine this circle in the sky. There is no circle drawn in the sky. They have to imagine a circle, this dashed line of the orbit of the moon, which is also imagined. It's not there in the sky. There is no circle drawn in the sky. And now comes the third one, the point of intersection of the two imaginary circles and then an imaginary point that is called the node. And the interesting thing is that this is the node which moves once in 18, that means after 18.6 years, this comes here and N2 comes here. So that is the periodicity. But the other interesting point is that it moves in this way. Sun, if you think, is moving this way, moon is also moving this way, but the node, Rahu, is moving in the opposite direction. So to understand all these things, it must have taken them several centuries, and that's the challenge. So finally, they were able to decode all these complex dynamics that are happening in the sky, and they were able to understand that the real cause of the eclipse is the fact that the sun and the moon are not in the same orbit, but then the orbit is slightly inclined. This I have a video at the end of the thing, 1 minute video made by Vignan Prasad. I will show where this is explained very nicely. So we have understood what is Rahu, what is Ketu, and now comes the interesting point. How do we fix the position of Rahu? How do we fix it? It's an imaginary point in the sky. How do we fix it? That's the challenge. So you have to first get the position of the sun and the moon. How do you do that? It starts with that table which I had shown in one of the previous slides. It makes so many number of revolutions in this many 4.32 billion years. So from a fixed day, when we consider that the position was at our 0, we fix a 0 point in the sky. how many revolutions it has made till today. Okay, so that is the first thing that we have to calculate. Obviously, it will not be an integer number. So it would have completed the number of revolutions and would have moved by some angle. That is the angle that we have to calculate. That fixes the position of the sun in the sky. Same thing with the moon, of the moon in the sky. And not only that, we have to fix the position of the node also, Rahu. Rahu also we have to fix in an exactly similar way, although we don't see it. Because if Rahu is quite far at the time of new moon, then there is no eclipse. If Rahu is within, say, 6 degrees, 5 degrees, or 8 degrees, as specified by the text, then there is an eclipse. Otherwise, there is no eclipse. Then we also have to find the speeds. You know, the speed of this moon or the sun is not uniform. In those, all of you have studied physics, so you know that in an elliptical orbit, according to Kepler's law, it moves faster when it is closer to the Earth, and it moves slower when it is farther at the apogee point. So all this we have to find out at the time. First, we have to find where they are, find out what their speeds are, and find out when they will come for a conjunction. That means they should be appearing in the same longitude or in the same position as seen from the Earth. And then we have to fix that instant. In new moon is not a day, full moon is not a day, it's an instant. We have to fix that instant. And then find where the node is at that instant. And then we have to estimate the diameter of the shadow if we are working on lunar eclipses. Okay, so let's say this is the Earth and that is the moon. So this is the shadow of the Earth, and this is a very simple high school geometry. You can use the property of similar triangles and get what is the size of the shadow here. What is the size of the shadow here? And you have one triangle here and another triangle here. These two are similar triangles. You have one more triangle here and one more triangle here, two similar triangles. So in terms of the radius of the Earth, in terms of the distance to the moon, in terms of the distance to the sun, because that decides what is this, you can find out what is the shadow radius. Now, this is from the mathematical component. But before this itself, they knew what was the shadow radius based on observation. How did they do that? You have to watch when the eclipse starts and when the eclipse ends. You know the speed of the moon. If it has to cover so many yojanas in so many hours, that should be the diameter of the shadow. So this is how they were able to do this. That means this thought process is the thing that you need to appreciate in all these things. And if you are mathematically interested, you can draw this diagram and try to calculate the diameter of the shadow using the, now you have all the values available, diameter of the Earth, you know, diameter of the sun, you know, diameter of the distances, you know, so you can construct a similar triangle and work it out yourself. Okay. I give an example from the text of 14th century. His name was Ekanatha. This particular manuscript was available on paper. It was copied later by in 1797 and is kept safely in the archives. And so the name of the copyist is also here. Ekanatha lived in a place called Mahad near this is about 30 yojana. Yojana was the unit of distance. So this is the meridian, standard meridian from Ujjain. All calculations are done from Ujjain. So you need this distance. You also need the latitude of this place, how much north to the north of equator this is. I'll just explain those points now, how exactly he did. So he starts with the Shaka number, that's the year count. And based on that, calculates the number of revolutions, how many revolutions it has completed. That gives you the average mean value. And once you get the position, you correct it for the elliptical orbit. So there is a procedure for that. So he explains what is the procedure. And then he corrects it for Mahad, because these corrections and the formula are all provided for Ujjain. And then you have to find out when the longitude, when I say longitude, I don't mean terrestrial longitude, the longitude as measured in the sky of these points. So from Aries, we start measuring. Aries to Taurus is 30 degrees, 60 degrees, and so on. And that is the word that is used here as longitude. When the sun and the moon have the same longitude, they are in the same direction of the sky, so it is a new moon. When it is 180 degrees, they are 180 degrees away, and therefore it is a full moon. That's how the new moon and the full moon are defined. Then they check the possibility of eclipse. How do they do this? They find out where Rahu is. And based on that, you calculate it. So this is the mean orbit, circular orbit. When you put a correction, those smaller circles are called epicycles and so on. I don't give the details of those. But the whole exercise is to make it an elliptical orbit. That's the elliptical orbit. That gives the true position, the actual position. And then the rest of the this is done for the sun and for the moon and for Rahu, all of them. So here it is. So now I have shown the sky like this as a circle. So here is your Aries, Taurus, Gemini, and so on. So on this particular day of 16 January 1367, the sun was here and the moon was here. So exactly 180 degrees away. Therefore, it was a full moon. And then this was the size of the shadow as the calculated size of the moon. And that was the size of the shadow. And where was Rahu? Rahu was here. See, very close to the moon. And therefore, it was an eclipse. And how much of the moon was covered? Was it total or partial? That is given by this, the difference between the center of the moon and the center of the shadow. And that is called as grasa, how much is covered. So all these details are given by Eknatha in the 14th century itself. We were lucky to have a solved example for this particular thing. So we were able to understand every process of the calculation they were doing. Otherwise, it would have been a mysterious thing for us. So the challenge lies in not only the prediction of whether it is happening, but you also have to find out the timings and the amount of obscuration. So how do you find the timings? So you have to assume the size of the shadow, the speed of the moon taken to traverse through the shadow. So when the partial eclipse begins, when the total eclipse begins, when the total eclipse ends, and when the partial eclipse ends, all these timings are all calculated. And then, depending on whether you are in Bangalore or in Delhi or Moscow, the orientation changes. So whether you will see a partial eclipse or whether you will see a crescent like shape this way or this way will be decided by your location on the earth. So you have to calculate the corrections for that also. And you have to verify all this with actual observations. So the example that I showed matches perfectly. There was no ambiguity at all in the 14th century. But by 19th century, there was a discrepancy. So the European astronomers, Britishers, they had already landed here, and there were very heated debates with the European astronomers and the traditional scholars here. And it was demonstrated in the open for a lunar eclipse. And there was a time difference in what traditional astronomers had calculated. So they had to sit back and estimate the direction that is needed, where is the error coming from, and all those things. This is all a very interesting thing that happened. And as you know, finally, towards the end of 19th century, Ketkar came up with a very good solution, and people started following what is called as Ketaki Panchangam. So in the medieval period, we were Dr. Shubha gave a lecture in the forum a few weeks ago. She told you about all these people. So these were all the people whose manuscripts we studied together, and two of them give a beautiful picture also. This is the picture of a solar eclipse, and this is of the lunar eclipse. So they have explained what is the meaning of this, the grasa, and how it approaches from this side, and how it, no, this is solar eclipse, so it is going from here to here. and so on. So similarly, this is the size of the shadow. This is the moon, which is entering the shadow. Khagrasaha, so it is going to be total. And Unmilana, Nimilana, these are all the words that are Sparsha, Moksha. This is Sparsha, this is Moksha. All these words are given here. And this is a medieval period drawing that we were able to access. And Shubha perhaps has given these descriptions in detail. So the celestial shadow play, effectively, you need a source of light, an opaque object, and a screen. That's all. These are the three basic requirements. And as you have been told in your school, you need a candle and then an obstacle, but then to see that there is a shadow, you need a screen also. So this is provided in the sky like this. So you have the sun providing the source of light, earth is giving the shadow onto the moon. Moon is the screen. In the case of the solar eclipse, it's the moon whose shadow is projected on the earth. So it's a very simple shadow play. We have to understand it that way. I think it is explained in the schools textbooks also, and a diagram like this would have fetched you some 10 marks easily. So all of you would have drawn this drawing. So this is a colorful rendition of the same. So this is solar eclipse, and here you have the moon, and then you can see that the shadow is a very small size compared to this. So people will get opportunity to see total solar eclipse very rarely because of this reason, because the width of the shadow is very small. On the other hand, lunar eclipse, many would remember because half the hemisphere, yesterday's eclipse, people from America also saw, we also saw. Okay, so all the people had seen the eclipse. So these are the things which you have already enjoyed, I think, in the last decade. There were examples in India. So this is the total eclipse where the moon is able to cover it completely. And by virtue of the elliptical orbit, sometimes the moon is appearing slightly smaller, in which case it can cover only this way, and you see the sun as a ring outside it. And this was a beautiful thing which was photographed by many people. I think all those who saw this eclipse will still remember it as a memorable event. So this is a total eclipse. This is called annular eclipse. The people have recorded this also. Annular eclipse was called as a Valaya Grahana. Valaya is a bangle that's worn on the thing. Look at the sky. So the lunar eclipse of yesterday, it was passing through like this. So all of you have seen it. So there is not much charm because it's already over. So when it is inside the umbra, so what is umbra? Umbra and penumbra, they are explained to you in the school. But how exactly you can demonstrate it yourself, that is possible. Okay, okay, next one. So this is the, where is umbra penumbra? I think it's in the next slide. So now you saw the moon like this yesterday evening. So this is the shadow. So I can imagine how big the shadow is. The shadow is almost 1.5 times of the size of the moon here. Okay, so the umbra and penumbra, okay, here it is. So this is umbra, this is penumbra. You can create this. How do you create this? You use a candle and do this exercise just to see the shadow of your hand on the wall. It will be an umbra. But you switch on a tube light. Then you will not see the shadow like this. That's because the source of light is extended, very large. That's the thing that is happening here. The size of the sun is so large compared to that of the earth. Therefore, you have umbra and penumbra also. In principle, the eclipse begins when the moon enters here into the penumbra. And we will start noticing it only when it enters the umbra. When it is in the penumbra, we are not able to make out a small change in the brightness because it is here. Only this much of light is not reaching it, but the rest of the light is reaching it. So this concept of penumbral eclipse was not there with the our old records because there was no way of recognizing it. And although we define it by straight lines like this, in reality, it is a very diffuse thing. So you cannot put a boundary and say that here it ends. For example, in the here, you see, this is the animation. You can see that you cannot definitely define a sharp boundary for the penumbra. So it's very difficult to make out that. And in this case also, defining the size of the circle shadow is very interesting. You can do that with naked eye, but not with a very high resolution photograph. As you can see here, it is sort of becoming diffuse. So whether there can be a partial eclipse? Yes, partial eclipse is possible, as happened here. So it is passing through the umbra, but not fully. You observe carefully, this portion is still in the penumbra. So this is not a total eclipse. And there is a possibility of penumbral eclipse also. The moon can pass like this only in the penumbra. That's a challenge. So it's very difficult to make out that there is a small change in the brightness of the moon. Very keen observers only can make out this. I distinctly remember a gentleman from Udupi. He used to go to the beach every evening and spend the evening there watching moon rise, moon set, and so on. So one particular day, he saw that the moon was unusually dull. Those days were the days with no cell phone. So he called me on the landline next day and asked me why was the moon looking very dull yesterday. There were no clouds and the sky was perfectly clear. But still, I feel the moon was very dull. I was immediately able to appreciate his keen observation because I explained to him that it was a penumbral eclipse. Over the phone, I had to explain to him, but he understood. So the penumbral eclipse is a challenge. You have to next year. So please try to see whether you can observe a penumbral eclipse. Okay. So then the next question is about the color of the moon. All of you have seen moonrise and sunrise. They are all red in color. What's the reason? The reason is our atmosphere. So an observer is standing here and this sun is still below the horizon, but the atmosphere here will act like a glass slab which bends the light, and it will also scatter the light. So blue light will go away in all directions, only red light can pass through. So we'll see the sun as a red disk even before it comes to the horizon. This is his horizon. And that's the reason why you see the sun red in color, and it's not at all harmful to look at the rising sun. Its brightness is diminished by such a thick layer of the atmosphere here. Okay, so here. The same thing happens during eclipse. So this is the picture I showed you earlier. But now what happens during there is a, this is the earth and it is surrounded by an atmosphere. So that's the atmosphere, let's say, it is surrounded by this. So the light enters from here, and because of the same phenomenon that is happening here, it bends. Okay, it's able to reach the moon. So what is the light that is reaching the moon? Red light. And therefore the moon will look red. The moon may not be rising, it may not be below the horizon. But because of this factor, when it is in the shadow, it should not be receiving any light from the sun in principle. But because of this, it receives the red light, and so it will look red in color. This red color will be different for different lunar eclipses. That is another interesting thing that comes out of this study. So in the year 1884, the moon was not at all visible. It was completely dark. Whereas in 1888, it was orange in color. So when they say that it is always blood red moon, it need not be true. So what was the cause of this? Then one scientist took all the observations recorded by all previous people, and then he was able to associate it with the volcanoes. You might have heard of a famous volcanic eruption which happened just before 1884 eclipse. And this ash had filled the sky, and therefore it was acting like a shield It was preventing this kind of a phenomenon to put light onto the moon. And therefore, the color of the moon during the total eclipse is an indicator of how much of volcanic dust is present. So you have to monitor that also. And now this has been given a scale, it is being studied systematically. These are hand-drawn paintings. That's why I showed them. So even with your own naked eye, you will be able to make out that there is a difference. And if you are observing every lunar eclipse, you will say last year's lunar eclipse was different from this. There is a difference in color. And I distinctly remember the one in 92 or so, when it was completely dark. It was something like this, as dark as this. But subsequently, there have not been many volcano eruptions enough to cause this kind of a trouble. So we have been seeing orange. It's actually orange. You all have seen it with your eyes yesterday. But the newspaper people prefer to put it as blood red. You know, they like that number, that phrase. So these are all very interesting things that you have to observe and note. So, okay, this is another example in 2003 and 2000 November. In between, just before this, in April, there was a volcano eruption. So you see the difference in color. And now, these are two photographs. I'm concluding now. These are the two photographs of lunar eclipse. Just by looking at, this is a question I'm asking you. Please think about it. Can you make out whether it corresponds to moon rise or moon set? Can you make out which belongs to moon rise and which belongs to moon set? Are they both moon rise and moon set? I'm asking this because yesterday you would all have seen, or at least the photographs you have seen. This is the kind of observation that you have to make. So why should we watch them? They're celestial wonders. It's an unforgettable experience. You can observe them just as our ancestors did. You don't need a telescope or anything. And you observe carefully and try to grasp the finer details. And you don't need any gadget. So don't miss any opportunity. The next one is ahead 31st December 2028. But before that, you have penumbral eclipses. So please observe them. And okay, this is a photograph of a solar eclipse. No, one of my students took this photograph. It's very interesting. So these kinds of artistic things you can create during eclipse. This is a solar eclipse. So please observe. Don't miss any opportunity to see the eclipse. And they are safe. Nothing will happen to your eye. Only in case of solar eclipse, you have to take precautions not to look at it directly. You have to use goggles, or you can project, but otherwise lunar eclipses are beautiful. So please watch them whenever you get an opportunity. So thank you. I conclude here. If there are questions, I will answer. Otherwise, I will show a small video, 1 minute video. Is that okay?
Yes, ma'am.
Okay, here. This is made by Vignan Prasad. See, it explains. Are you able to see it? Yes. You are able to see? Okay. So this explains
Yes,
all the periodicities and the different in the orientation very nicely. So this is the sun and the earth going rounded. Okay. And then they will introduce this is perihelion when the earth is closest, aphelion when earth is farthest. They're exaggerated. So this is called the plane of the ecliptic. And that's the moon going around the earth. So it is closest at perigee, farthest at apogee. And then the two are in different planes. So the angle between them is very small. It's just about 5 degrees. Okay, so how the eclipses happen? So these are the 2 points called the descending node and the ascending node. Now you see the node is also moving. And now there is a possibility of solar eclipse. 15 days later, there is a lunar eclipse. So always you will have them come together. Again, you have 173 days later, another possibility. So this is solar eclipse again. So if one is Rahu, 6 months later, you will have Ketu, ascending node and descending node. And this keeps on happening. Okay, so many cycles they show. So this is, the difference is not 1 year, but it is slightly less than that. This is called 173 days cycle. Another cycle, and then it goes on. This they will show fast, showing that so many cycles would have happened. And finally, what happens? Let's see. So this is after 18 years, 10 days. See, they have come back to exactly the same point. Similar eclipse occurs. This is what I explained in the thing. Okay. Oh, sorry, this is not needed. Okay, I'll stop it here. So if there are questions, I will answer.
Participants, if you have any question, you can ask.
I'm not able to hear. Can you repeat?
Ma'am, your voice is breaking. Can you put your
Voice,
question in the chat box? Your
yeah,
voice is breaking.
I was not able to make out.
Put your question in the chat box. I will read it.
May I talk now?
Yes, please. You have a
The
question?
things you have discussed are very well explained and very illustrative. That means we have understood everything.
Okay.
But how
Thank
to
you.
make these things aware to our students, especially high school students and students till 12th of class?
See that.
There are maybe there are several softwares or models or something known
Yeah, softwares
available.
are all there. Softwares are there, apps are there. All those things are very nice. But unless they do something with their own hand, they will not remember it. This is from my experience. So I make them derive the shadow radius. Okay, this is high school geometry using similar triangles. So high school students can do this. First, they will do it, and then you put the question. All right, you took the values from internet, and you said that this is a shadow radius. How did they do it 2000 years ago when there was no internet? That is the way you have to build up their interest, and they will be able to appreciate the effort that has gone into understanding these things.
Okay.
And
Ma'am.
this concept of two being different, there is a small difference in the angle. It requires a lot of patience to observe that and understand it. So, night sky observation, showing them that, okay, today the moon is able to pass in front of the star Magha. Whereas next month, 27 days later, when it comes again, it is not doing it. Why? So it has moved slightly off. So this requires a lot of patience. But people are trying to do that with the things like that. That may also help to some extent.
Okay, thank you. This is one way. My another question.
Yes, please.
What your talk is very nice. I don't want to criticize you at all, but the things that have been attached in our culture related to this type of eclipses and all that, maybe solar eclipse or lunar eclipse, etc. It's very difficult for physicists to make the people, very common people, to understand about the very scientific and
Yes.
physical phenomenon.
They think that you are Gnostic.
Huh?
You don't believe in God and things like that, But
No. To get the read out, that means there should not be any harassment of people or anything like that.
Yes, yes.
So it's very difficult for physicists to make the people aware about this very pure and scientific phenomenon.
Yes. So the best way is to teach them in the classroom. In the
Hmm.
classroom, you don't teach them at all, right? You never teach them any science. It's not in the curriculum. So they don't get to know about it at all. And the only thing that is in the curriculum is drawing the diagram of the eclipse. I also did that. You also did that. As I said, it gives you 10 marks. So it's a beautiful diagram and it ends there. They're not able to extend that to the sky. The same thing. That's the problem.
Yeah. Thank you, ma'am. Thank you. Very nice.
But, madam, pardon, madam. I'm
Yes,
Chandrasekhar speaking from Andhra Pradesh.
please.
But what you are telling is very nice and excellent, madam. I understood very easily, and it's very nice talk to you, madam.
Thank you.
I'm very happy with participating in this one. But my doubt is also what earlier our sir is also asked the same thing, that astrology and astronomy, these two are very
Yes.
comprehensive one with each other. And nowadays, even though some of the universities also placing this astrology, and
But
this
you are in Hyderabad. You are in Hyderabad.
not
Osmania
madam.
University.
Yes, ma'am.
Osmania University has
Yes,
a
ma'am.
department of astronomy, very old. Maybe it's 100-year-old. I don't know. It existed before independence, I think. One of the strong centers of positional astronomy. So you have to approach them and make them teach school students and all these what to say, people with half knowledge, so that they understand the science part of it. That's the only solution. You can remove ignorance only by imparting knowledge. Okay? You will have gnana only if you remove ajnana. Otherwise, it's not possible. So you have to patiently wait. That's all. See, if 20 years ago, 30 years
Time
ago,
will
when there was
decide.
an eclipse, even 30,
Okay,
40
ma'am.
years ago, when there was an eclipse, it used to be a curfew. People
Yes,
would
ma'am.
not come out. Now, today it has improved, right? Some people at least come out and take photographs. So,
Yes, madam. Yes, madam.
so that way, there is a slow change. And so let's hope it will make people think rationally.
Okay, madam. Thank you, madam. Thank you very much.
Thank you.
Ranjita madam, you want to ask something?
She didn't write it, is it? She didn't write the question?
No, she's.
No.
Ma'am, your voice is constantly breaking. Ranjita ma'am, can you put your question in the chat box? Please put your question in the chat box.
We are not able to follow. Any other question?
I think there is no question.
Okay.
Yes, Professor Bharat, I want to share with you that every video of NASNI, which is recorded on first and third Wednesday, will put it on IIPT website.
Thank you, ma'am. Thank you.
So you will get the before videos also which are recorded. You can access those videos also.
Yes,
I see.
thank you.
So should I end, ma'am? Should I conclude?
Yeah, you can. I thought she would be able to write something in the chat box. She has not written, so maybe it was a comment, perhaps. Okay. You can conclude. I thank you all for the patient listening and the question answers, and so I was able to communicate whatever I wanted to say quite effectively. Thank you.
Thank you so much, ma'am, for this highly informative and engaging talk. Your explanation and on eclipses and their importance in astronomy has truly deepened our understanding. On behalf of NASNI and all the participants present here, I extend our heartfelt gratitude to you, ma'am, for sharing your time, experience, and wisdom with us today. I would also like to thank
Thank you.
our coordinator, Professor Hemant Kumar sir, for
Yes.
organizing this wonderful session and for his constant guidance and support. Dear participants, thank you for your enthusiastic presence and active listening. With this, we come to the end of today's NASNI talk. We look forward to meeting you again in our next session. Wishing you all a pleasant evening and clear skies ahead. Thank you so much.
Thank you.